Let's move on and have a look at the sketch now. In this sketch, you can recognize the first two inclusions, the Ethernet and the SPI libraries, nothing new here. For this particular sketch, I'm also going to use an external C class, or C++ class. It's a pstring, and this class is really nice in helping us putting strings together. Now, the information that this sketch will be sending to the Nimbits server is a HTTP post request, and as you remember from previous lectures, HTTP requests are made up of two parts, the header and the body. So I'll be using the pstring class to help me put the header together first and then the body content. So I'll show you where to get the pstring class first from. So we go to the Arduino website, and it's a really nice place for finding very useful libraries, and one of those is pstring. So this page contains information about pstring, examples of how to use it, and if you scroll towards the bottom of the page, you will find a link here. So pstring3.zip, click on this link to download it to your computer. Once you have the file in your downloads directory, make sure everything is in it. You can copy it and paste it in your Arduino IDE's library directory. I'm not going to paste it now because I've already got a copy. It works just fine, but that's where you need to place it. And once you finish with this, don't forget to close and start your Arduino IDE so that the changes take effect. So that's all you've got to do in order to install these class libraries. So let's go back to the string, to the sketch. So because our post request is going to be made up of two parts, we set up two arrays of cars, buffer and content, and we set up the maximum sizes of the maximum number of cells that each buffer or each array should have. So the content array is going to hold the data that I'll be posting to Nimbits, and buffer is going to contain everything, which includes the HTTP request header plus the contents. Those two will be appended to one another. So I use the pstring class to create an object called str, and I initialize this object with a pointer to the buffer. So you can see that I'm making a reference to the buffer array of cars, and I also need to pass the size of this array of cars, and to do that I'm using the size of function that comes with C. I give it a reference to the array, and that will return the number of bytes that this array takes up. And I did the same thing for the second pstring object. It's called cont, and that's going to hold the data that I'll be posting. Now in this example, I'm taking two analog readings from analog pins 0 and 1, and I'll be registering or saving those values in these two variables. This block is familiar. I'm just setting up my Ethernet communications and Ethernet networking parameters. Now here I'm setting up two variables that I'll be using to restrict the amount of posting that I'm doing to Nimbits so that it's not excessive. I don't want to post every single time that I'm going through the loop, but only in this case once every 10 seconds or even less than that. I'm using 10 seconds for now, so posting interval, which is an unsigned constant long, so a large integer, setting that to 10,000 milliseconds. But I'm doing this just for this testing phase of the sketch. Once I'm happy that the sketch works fine at the 10-second interval, I'm going to change that to 120 seconds, which for the data that I'll be collecting, just light intensity, is enough. And I don't want to put too much strain on this public and free server that I'll be posting to. This variable, another long integer, I'll be making a mark of the last time that the sketch posted to Nimbits. Then I'll be able to subtract last time of the posting minus current time, and it will be giving me the difference in milliseconds, and from that I'll be able to calculate whether it is now time to post again or not. I'll show you the actual code very, very soon. Now, next two variables contain information that the sketch will need in order to authenticate itself with Nimbits. So I need two pieces of information. That's the email address that I used to create my account, and the posting key that I acquired from my account after I created the post key. So with that, the preliminary done, just setting up the Ethernet connection and get a handle to the serial ports I can use for my monitor, just like we've seen before, and we get into the loop. In the loop, I take measurements from analog pins 0 and 1, call the doWeblog function, and in here I check to see if it's first time to post, and that happens right here. I do a couple of checks here, and those are joined by the Boolean AND operator. So both sides around the AND operator need to be true in order for a new post to go underway. So the first thing that I check is to see that I'm already connected to Nimbits. If this highlighted portion of the test returns true, then that means that my Arduino already has a connection to Nimbits. It's probably working on a posting that hasn't finished before. Usually that happens if your posting interval is very low, so that by the time that the posting finishes, the Arduino has gone back into a new loop function. So anyway, I want to make sure that this doesn't happen here, so I'm only going to proceed with posting if this segment, this call to the connected function, returns false. And with the bang operator, I can inverse that so it becomes true. So once this bit is true, then with the Boolean AND operator, I'm going to go ahead and check the right side of this test. So here I'm checking that time now, which is acquired using the millis function, minus the time that the connection to Nimbits was established last, is greater to the posting interval that in this particular case is 10 seconds. So if it's been more than 10 seconds than my last posting, let's go ahead and create a new posting. And that happens in here. First thing that I do is I will initialize the two p-string objects using the begin function. That basically clears up any content that may have been left over inside those p-strings since the last posting. So I clean those up and then call send data. So this is another function, and in send data I construct the HTTP request. And I start by using the cont p-string and print elements in it, one after the other. So start with the credentials. So set the email, so print email, and then pass the mail address variable that I created earlier. Got the join for the next key value pair. So I've got the key value, the key name for the value pair, and then the key is the key that I initialized earlier, so the posting key from Nimbits. So credentials are done. Moving on to the actual data. So using another ampersand to connect a new key value pair. And the structure that Nimbits is using is that it's using the pay key followed by a number, and that number, an integer, indicates the number of data points, incremental data points that I want to post. So this one is going to be P1, and the name that I need to put for P1 is the name that I chose to name my data points. So I've got TP1 here and TP2. So first we'll set P1 to be DP1. A new key value pair connected by the ampersand symbol. I'm going to call that V1. So this is a counterpart of P1. And here I want to post the value that I captured from analog pin 0. So that's ANA1. And I'm marking that as to be posted as a decimal, not a byte or a binary or something else, or hex perhaps. Now repeating the exact same thing for the second data point. So that's all with the data and with the cont p string. I'm going to now go ahead and create the header of the post request. And to do that, I'm going to need to count how big the data is going to be. So I'm creating a new cont len integer variable, and I'm asking for the length of the cont p string here, and that's going to return the number of bytes that the body of the post request is going to carry. I'm going to need that in a minute as I'm putting together the header. So let's move on to the header. First, I attempt to connect. So if a connection is possible, then I'm going to go ahead and assemble the header. So start printing the header line by line. Notice here that I've got the content length part of the header, and I'm going to output the actual length or number of bytes that the body of the post request is going to contain. Empty line, finishing up with the content type. Notice that there is an empty line at the end of this printout, plus another empty line right after that. So I've got an empty line after the headers have finished. That signifies that it's time to print out the body of the post request. So this is where I print the contents of the cont p string. And finally, the whole thing finishes with a new empty line. That's about it. I use a serial interface to send some messages out to the monitor, and then print out the request to Nimbits. If I want to see what Nimbits sends back to me, especially a confirmation, then I can use this block. I can comment that out after all my testing is completed, so that I don't take any processing power from the Arduino. But what happens here is that if the Nimbits server is sending data back to the Arduino, so data is available, then read it and print it out to the console. Which again, this is something that we have seen earlier in the lecture on the Arduino server. So we see what the output of that is once I run the sketch. Last thing we do is to grab the current time and save it in last connection time, so we can do our next comparison later on and make sure that we only send out a new post request after the minimum interval has been completed. So let's upload that. Okay, done uploading. Have a look at the monitor. We'll wait for a few more seconds for the first posting. Okay, so the first posting was completed. You can see the content length in 98. This is the body of the request. The first part makes up the authentication part, and then the data follows. And following that, we have the response from Nimbits. So this part here is the response, and that was produced by this block of code here. So the last maybe 30 seconds we had maybe 2 or 3, maybe 4 postings. So let's go to Nimbits and have a look at what we have. I'll refresh. Drill in. So these two are the latest values. They were just sent over by the Arduino. And if I just double tap, double click, I can have a look at the plotted, the plotted values. It's charted. Try again. Okay, takes a few seconds for the chart to compile, but there you go. So these are values that I have in here. Obviously these ones up here are the latest ones. I've had this sketch running for a few hours before recording, so you can see what the chart looks like. Yep. Apart from that, apart from just looking at the chart, you can also download the data onto your computer for further processing. So there's this function here called schedule a data dump, and clicking on that, submitting it, you tell it which data from when to when you'd like to compile and put together in a text file, which is emailed to you. It's a comma delimited file, but what you get eventually. So there you go. Sending data from your Arduino to a service like Nimbits using HTTP requests is truly very easy. Now that you know how to post sensor data to sensor values to Nimbits, go ahead and make some use of it. Add a DHT sensor to your circuit, extract humidity and temperature values from it, and post them to your Nimbits data points. Record values for a few days and see how they fluctuate over time. Add a barometric pressure sensor and a photoresistor and record all 4 values for a week. Get the data and plot them all together in a spreadsheet. Can you see a correlation between the 4 measurements? For example, can you confirm that humidity in your area is higher at night than it is during the day? These are just some of the things you can data log in order to capture for a prolonged period of time and then do data analysis on them using simple tools like Excel.